Hello and welcome to this lesson about thermal comfort. In this lesson we will define thermal comfort, talk about the physical parameters involved, and present the two indexes to measure thermal comfort. By the end of this lesson you will be able to define thermal comfort, to list the factors affecting it, and also to name the two most common indexes. So what makes you feel comfortable inside a building? This question, maybe you think about many things, many possible combinations, but remember that we're talking about HVAC systems in this course. So there are three parameters that are going to be related. Those are temperature, air velocity, and humidity. And we will say that what makes you feel comfortable is about the range of temperature, range of humidity, and range of air velocity that makes you feel in a neutral sensation. So first start with a formal definition, that is, according to ASHRAE standard 55, thermal comfort is that condition of mind that expresses satisfaction with the thermal environment and is assessed by subjective evaluation. So this will say something that is more or less that if you feel warm or cold, or an indoor environment is too humid for you, so this will be related to that. So from this definition, we say that thermal comfort is a psychological state. So the conditions will be different from person to person. And let's remember, there are three parameters that are related to it. So there are temperature, humidity, and air velocity. Those are related to the HVAC systems. And if we use our own personal experience, we know that not everyone feels warm or cold to the same conditions. But even if we have difference between the persons inside a building, we should have the goal to create indoor environments that are comfortable for most of them. To assess this range of velocity, temperatures, and humidity, many experiments were run. In these experiments, the professionals use climate control environments, and they expose test subjects to different environmental conditions. And in each of these conditions, they ask the subjects if they feel cold, warm, comfortable, or uncomfortable. Then these results were used to assess the comfort zones in temperature, humidity, and air velocity. One important thing that they found is that this range will be different according to the activity level of the subject, and also according to their clothing. So in these experiments, they used this ASHRAE 7-point thermal scale. It goes from cold to hot. And the average of these both that all the test subjects had inside a specific indoor environment, it's called predictive mean vote, and it's one of the indexes that we are going to use to define thermal comfort. The other index that is very important is the predictive percentage dissatisfied. It tells us how many people what is the percentage of the people that is going to be dissatisfied in a specific indoor environment. So the combination of these two indexes are used. And here we see the relationship between them. We see also the 7-point scale according to ASHRAE. And here we can notice that even when the subjects, the average answer was 0, was neutral, we had there were a group of subjects that had some discomfort. So from this graph, we learned that there is no environment that is going to be related to a 100% of occupant satisfaction. In this graph, we also have two vertical lines. This range is the range that is going to be our goal when we are designing a building. So here, in these limits, we see that it's related with a 10% PPD. So we can say that in our designs, we are striving to get a 90% of occupant comfort. So from this lesson we have some key takeaways. So first, thermal comfort is a psychological state reflecting satisfaction with the thermal environment. Then the physical parameters controlled by HVAC systems that influence thermal comfort are temperature, humidity, and air velocity. Then we have the PMV and the PPV index measure the level of thermal comfort in an indoor environment. And then finally, we just said that building design should strive for 90% of occupant satisfaction to ensure optimal thermal comfort. So I invite you to continue learning with other videos in this course about calculation of PMV and BPV, representation of thermal comfort zones in a psychrometric chart, and further information about the physical parameters involved in thermal comfort. Thank you.